Hi everyone, welcome to the part 2 of the demo on Nebula. This is in continuation to a project I am working on, so let's get on to it. So, the last part was mainly about testing the idea of using LLMs in stock picking and stock analysis. I definitely saw some consistency and coherence with how stock analysis works in the real world, so this is in extension to that research. What's different this time is that I have separated out the qualitative and quantitative analysis aspects of the share. What a lot of research papers are doing nowadays are they're sending a company's financials to the LLMs. However, I think that LLMs should be reserved for the textual analysis part because the financials and the numbers part can be automated through programs. I have also shifted from a multi-agentic collaboration strategy to a more standard prompting strategy. I did this because I think not a lot of decision making should be entrusted upon to the LLMs. It should be thought of as an assistant system, right? So, by actually fixing what we need from the textual analysis, we can actually improve the consistency and reduce the errors from the bias or randomness or hallucination. So the system is pretty straightforward. First, it takes a human curated investor profile, which is essentially a highly detailed list of specifications and parameters for assessing the stock. It is divided into quantitative and qualitative aspects. For your information, further in the video, I might call them as analysis aspects, parameters, or frameworks. They're essentially the same thing. Each parameter has a tool and a weight. A tool retrieves information about the company which is relevant to that parameter, and the weight signifies its importance. On the right, we can see the analysis output of the system on a single stock. We see the fundamental score, the technical score, and the qualitative score. The qualitative analysis takes place in multiple iterations on the same prompt, as variations in LLM output may be unpredictable. Each column represents the score from each iteration, and their weighted average is termed as the final qualitative score. Let's have a look at how the quantitative scoring works. Most scores by stock analysis website or tools are based on a fixed threshold based binary 0 or 1 scoring. For example, a check might say if Q on Q revenue growth is greater than 10%, give it 1 point else 0. But that's not very efficient for a case where the value might be, say, 9.5%. However, in this system, the financial or technical ratios value is mapped onto a curve so that any positive or negative deviation from our desired threshold can be respectively reflected on the score. For example, we have a parameter OPM, which is the operating profit margin. We define a midpoint, which is our preferred standard value for OPM. For a stock X, we will map its OPM onto the sigmoid curve. Now, as you can see on the graph, if that value is greater than our midpoint, it will lead to a higher score. If it's lower, then a lower score. This was an example in which we would like the ratio to have a higher value. Such ratios have type equal to higher. This was an example in which we would like the ratio to have a higher value. Such ratios have a type equal to higher. For ratios like P, which we want to be low, we set the type equal to lower, which means that instead of a sigmoid curve, we use an inverse sigmoid curve. Another type of ratio may be of the type sweet, where we might want the value to just be on the sweet spot, not higher or lower. For example, the RSI indicator. For that, we use a bell curve which fits appropriately. Finally, using the weights, we calculate a composite score for both fundamental and technicals. Now let's take a look at the qualitative scoring. This is the juicy part of the system, the USP. This is the part which allows Nebula to perform textual analysis. First, from a list of parameters in the investor framework, we choose one, say conference call transcript analysis. We take the rules described in this parameter and along with the transcripts and a carefully designed prompt, we send it to our LLM. In image 3, you can see that the LLM outputs a pointwise correlation analysis which explains how well the model thinks the transcript's contents aligns or misaligns with our framework. Additionally, we also ask it to generate a correlation score. We repeat this process for multiple parameters and for multiple iterations and ultimately calculate the weighted average qualitative score. Here you can see a few more examples of the tests conducted on various shares. The table contains metadata like the models I've used, the number of iterations, token usage, etc. Another important note, the scores are not necessarily good or bad on their own. For example, we don't know if a score of 75 is good or bad unless we compare it with other stocks evaluations on the same profile plus model combination. Next, let's look at some challenges that have occurred or might occur while trying to backtest Nebula's results. Firstly, the issue of lack of quality and historical data still persists, and the efforts to design data scraping and processing pipelines are still ongoing. Secondly, based on the token usage estimates in the previous slides, backtesting for 5 or 10 years would require significant computational resources. Standard backtesting metrics like cumulative returns, CAGR, Sharpe ratio, etc. might still be misleading due to inherent challenges in trading strategies and LLMs. For example, look-ahead bias in LLMs is a concern, which means the model might have used data on the company which we are trying to evaluate while it's training, and thus already have some kind of prejudice built into it, leading to inaccurate results. Survivorship bias, which means most of the times we focus on the few selected shares which has performed well or are famous. However, we often neglect the other thousands and thousands of shares in the market which did not perform well or people don't even know about it. Lastly, data snooping bias. This bias means that a strategy with a good backtesting result may not perform well on live trading, and the reason could be overfitting. Another way of saying it is, we might think we did well, we did everything right, but the strategy only worked because we looked too hard, not because it was actually good. Future work on this project includes expanding to other markets such as the US. That should not be too hard because of the way Nebula is built. It can work on diverse markets if we provide it with enough data sources. Currently, there are no data sources for macro, sector or industry analysis, so that's definitely on the list. Once individual share scoring is more concrete, we can move on to portfolio allocation and diversification, starting with equally weighted or mean variance optimization based portfolios. Lastly, I would like to make some important points regarding the vision of this project. Nebula is not to be compared with performances of quant firms or high frequency trading firms. The thought behind this tool is, how well can we simulate the decision making of, say, a mutual fund manager or a portfolio manager? Ultimately, long-term, consistent alpha generation would be considered a success. Thank you so much for watching till the end. I hope to come back soon with more results in part 3.